Welcome to Cognition Unleashed. If you want to master forces, you have come to the right place. This is the part where all the smart people can go ahead and subscribe to the channel. And don't forget to click on the notification button so you can stay up to date on the content and become even smarter. Subscribers may request content they would like covered. By the end of the lesson, you will understand number 1, what the basics of forces are. Number 2, the effect it can have on an object. Number 3, the two categories of forces that exist. Number 4, we then do a quick quiz. And at the end of the video, I unleash a small activity for you to see how much smarter you have become. Let's get started. So what are forces? It is a push or a pull exerted on an object. For example, when you push a trolley or break a chocolate chip cookie so you can share half with a friend, you are pulling or pushing the object, which means you are applying a force to it. We can measure these forces using a Newton meter. This is why force is measured in the unit called newtons and is abbreviated as a capital N. When you apply a force to an object, you can cause a change to the object. This can be in the form of changing the shape of it, for example, when you chew gum, or cause it to accelerate, like when you're racing through the aisle at the grocery store to get to the last box of cereal. You can also use a force to slow down an object to stop it from moving entirely. And when you are kicking a ball to a classmate on your right, the force you applied is changing the direction of the object. There are two categories of forces. These are contact and non-contact forces. Contact forces are exactly as it sounds. It means the objects are touching or in direct contact and causing an effect. This is why we talk about the objects pulling or pushing one another. Examples of contact forces are tension, compression, and friction. Non-contact forces are the exact opposite. Here, the objects do not need to be touching one another to cause an effect. The force can be effective over a distance. Examples of non-contact forces are magnetic, gravitational, and electrostatic forces. Let's dive into contact forces in more depth. When the surface of two objects slide against one another, as is the case with a trolley on the ground, for example, it causes the object to slow down or eventually stop. Friction opposes motion. The type of surface also affects how much it opposes motion. For example, think about skating on ice versus tar. Ice is smoother, so there is less frictional force. Tension and compression both have two forces acting in opposite directions on the object. However, with tension, the two forces are moving away from one another, stretching the object. Think about when you're trying to break a licorice twirl in half and you pull it at both ends, stretching it. With compression, on the other hand, the forces are moving towards one another. For example, when you press a stress ball, squeezing it. Gravity is a force of attraction between two objects with mass. The Earth has a gravitational acceleration of 9.8 meters per second squared. This is why when you throw a marble into the air, it comes back down. And why when we see people floating in space, we say it has zero gravity. You need to understand how to do calculations on gravitational force. Let us look at the triangle. Think of the W as a winner, and that's why it goes at the top. This line means divide, and this line means multiply. Therefore, W equals M times G. M equals W divided by G, and G equals W divided by M. But what do each of these symbols mean? W stands for weight and is actually measured in newtons, not kilograms. The M stands for mass and is measured in kilograms. Please note that mass stays the same wherever you go. Unless you have been going to the gym and building a bit of muscle, of course. It has to do with how much of atoms your body has. Weight, on the other hand, changes depending on where you are. For example, your mass might be 40 kilograms on Earth and the moon, but you will weigh more newtons on Earth than on the moon because the gravitational force on Earth is 9.8 meters per second squared, so it is higher than it is on the moon, where the gravitational force is 1.6 meters per second squared. Weight is affected by the gravitational force that exists. The G stands for gravitational acceleration and is measured in meters per second squared. As stated above, it is different on different planets and other astronomical objects. Now, what are electrostatic forces? When we rub two objects against each other, we are causing friction. This may transfer electrons from one object to another. The object that gains electrons will be negatively charged because it has more electrons than protons. And the object that loses electrons will be positively charged because it has more protons. These charged objects exert forces of attraction and repulsion onto other objects. If you look at the diagrams on the right, you can see that the negatively charged objects repel one another, whereas a positive and negative object will attract one another. So remember that like charges repel and unlike charges attract. It is our quick quiz time. I am going to ask you 2 quick questions. You may pause the video before I provide the answer for each question so that you can test your own understanding. Number 1, which unit of measurement do we use in order to measure force? The answer is newtons. Number 2, which non-contact force is caused by friction? Electrostatic force is the correct answer. Well done! You have unleashed the activity. Pause the video, set up a 7-minute timer and begin. Once you are done, you may view the answers on the next slide. Good luck for whatever upcoming exam you have. See you in the next video.